Hello, Algebra 1. Welcome to Lesson 8.2 on quadratic functions in vertex form. So the vertex, we know, is that point where the U kind of curves, right? So it could be the top point, which would be called the maximum, or it could be the bottom point, which we call the minimum. But the formula we're going to find out today is going to tell you directly from it what the vertex is, which is very helpful because we know that the vertex is on the axis of symmetry, and the part of the parabola to the left is going to be the same as the parabola to the right of the vertex. So very, 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 very important point when it comes to quadratics. All right, so it says, how does the graph of g of x equals x squared minus 4 compare to that of f of x equals x squared? So this is our parent function, right? So hopefully you remember 0, 0, 1, 1, 2, 4. Y-axis or axis of symmetry, so this point is over here at negative 1, 1. This point is over here at negative 2, 4. There is your parent function. And again, I'm trying my best to get good at these parabolas, but it's hard with this software. I have this tablet. Okay, so that is your parent function. That is f of x, the red graph. So now what is this g of x equals x squared minus 4 going to look like? Well, maybe you have a prediction because we have done this plus k at the end already, so maybe you have a thought of what's going to happen. But let's go ahead and do an xy table, right? So here's x. Well, we use our 5 values of negative 2, negative 1, 0, 1, and 2. Our function is x squared minus 4 that we'll plug it in. And then we will get our xy pair, x, f of x, as our xy pair. Or in this case, g of x, I should say, not f of x. Sorry, g of x. Whatever the function name is. Okay, so we're going to plug in negative 2. So we're going to do negative 2 squared minus 4. Well, negative 2 squared is 4. 4 minus 4 is 0. So the point negative 2, 0 is on our graph. Negative 2, 0. So notice right now what I'm seeing is that this point up at 4 now is down here at 0. It changed its y value down 4, right? That's kind of interesting because your k value is a minus 4. All right, so let's see. Okay, negative 1 squared minus 4. That's 1 minus 4 is negative 3. So our next point is negative 1, negative 3. Negative 1, negative 3. Again, this point down 4. Interesting. All right, we plug in 0. So 0 squared minus 4 is going to be 0 minus 4, which is negative 4. 0, negative 4. So our vertex that was 0, 0 is now 0, negative 4. Again, down 4. Plug in 1. 1 squared minus 4 is also negative 3. So we do have that symmetry across the y-axis again. So 1, negative 3. And then I bet when you plug in 2, you're going to get 0. And you do. So 2 squared is 4. 4 minus 4 is 0. So 2, 0 is also on there. 2, 0. And you can see that all 5 of those points on the red graph shifted down 4 to create this new parabola. It should look the same width. Right, that doesn't change, but the only difference is that this thing shifted down 4. So g of x is f of x, and I'm going to use the word translated. Translated, because that's what they like. Translated down 4 units. Down 4 units. So to generalize this, right? So when you have a k value, so in this case, g of x equals x squared plus k, right? That k is going to be a vertical translation, or a vertical shift. Again, they like to use the word translation. Vertical translation. And the vertex becomes 0, k. Right, so we don't move left or right. We just go up or down depending on what that k value does, and we go exactly what it says. So this said minus 4, so we went down 4. Right, so our vertex here was at 0, negative 4, 0, k. In the axis of symmetry and the axis of symmetry is still going to be x equals 0, which is the y-axis, which is this guy, right? We did not shift left or right. We just went up or down. So that vertical line does not move. It's going to stay right there. That is our axis of symmetry. So this is what happens when you have that k there. So understand that when we talk about vertex form, I think it's going to involve a k because you can see that that became the y of the vertex. All right, very important stuff right there. Try to keep that in mind. All right, next. Now what happens, right? What happens if we bring in another kind of shift to this graph? Okay, now how does g of x equals x minus 3 squared compare with f of x equals x squared? So now you notice that the movement, the minus 3, is now inside the parenthesis with the x. So k went vertically, so you wonder if this minus 3 is going to go horizontally because it's with the x, and that's the x direction. Again, all that transformation stuff we talked about earlier kind of come into fruition here. All right, so let's again put our general formula on there, right? So f of x, right, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Again, until you're blue in the face, right? It's always good to have a good idea of what that parent function quadratic looks like. Okay, so now let's build our table for g of x. So our x values are going to be negative 2, negative 1, 0, 1, and 2. And our f of x is going to be x minus 3 squared. And then we'll have our ordered pairs, which are x, g of x. Okay, so when you plug in negative 2, so it's negative 2 minus 5 squared. That's negative 7 squared, which is 49. Oh, I'm sorry. Wait. Negative 2 minus 3 squared, which is negative 5, which is 25. I was getting ahead of myself. Sorry about that. Oof. I was getting two ahead. So this is negative 2. 1 second. Let me just write it again. I'm not trying to change the function. This is negative 2 minus 3 squared, which is negative 5 squared, which is positive 25. So negative 2, 25. All right, we plug in negative 1 minus 3 squared. That's negative 4 squared, which is positive 16. Negative 1, 16. We plug in 0. 0 minus 3 is negative 3 squared, which is positive 9. So 0, 9. We plug in 1. 1 minus 3 is negative 2 squared. Negative 2 squared is 4. And then we plug in 2. 2 minus 3 is negative 1 squared, which is 1. So here's the points we have to graph, right? Now notice a couple of these are going to go off the graph, right? Negative 2, 25 is way up here. A negative 1, 16 is way up here, right? Now 0, 9, 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 1, 4, 1, 4, 4. And then we have 2, 1. So notice we don't even have the full kind of U shape, right? If you take a look at that, right? But notice that it's kind of going this way. Again, this is, I'm going to just use these points here because they're more, it's kind of going this way. So I wonder if this point right here is that point shifted that way, 1, 2, 3. So 3 to the right. So this point is this point here is this point shifted 1, 2, 3 to the right, right? So maybe your vertex is shifted 1, 2, 3 to the right. So there's your vertex. This point is shifted 1, 2, 3 to the right. This point is 1, 2, 3 to the right. And do you see how I've kind of developed now my right-hand side? And there's that parabola. So again, in other words, I would just continue to graph more points if I needed to, but don't need to here because we have an idea, right? This red graph is shifted to the right 3 to get to the blue graph. And notice that we talked about this before. When you're doing your horizontal translations, it's always opposite of what this says, right? When it's inside here, it's always opposite of that. So if this says minus 3, it's actually a positive 3, 3 to the right. Okay. And here's the graph. So in this case, g of x is f of x translated, again, big boy word, big girl word, translated, right 3 units. Right 3 units. So when you have an h shifting inside with the x, right, the overall theme is that g of x equals x minus h squared is a horizontal translation. And you are going to shift or move so that your vertex with vertex h comma 0. So now, again, notice, right? This is your h value. If it's a minus sign, the h is a positive 3. So notice that this vertex is a 3, 3, 0, right? And now the axis of symmetry actually moved. The axis of symmetry was the y-axis, but now if you look at this blue parabola, the axis of symmetry goes right down through the vertex. And again, we have to remember that the vertex, right, the x is 3, that's going to be the equation of that vertical line, x equals h. So again, this equation is x equals 3. That's the new axis of symmetry. That's the line at which the left and right side of the parabola are identical. And this is what the h is going to do inside with the x. It's going to cause a horizontal translation. All right, so I feel like my video is dragging on a little bit. So I'm going to stop here. I'm actually going to make 3 videos. Sorry for the 3rd video, but this is like getting long. So the next video is going to combine these 2. So there's going to be 3 videos today, not just 2. Oh, no. I apologize. Stay tuned for video 2.